Hello everyone. Today we are going to solve some of the problems related to mathematical induction. So our first question is this: prove that by the method of induction that 2 plus 5 plus 8 and so on 3n plus 3n minus 1 equals to this. So we are going to solve this question. At first today we make a statement about this. So let Pn equals to 2 plus 5 plus 8 and so on 3n minus 1 equals to n 3n plus 1 by 2. So we took the given statement as Pn. Now our aim is to prove the Pn is true. So first we check for P1. So replacing n by 1, we get LHS of the statement as 3 times 1 minus 1. It is 3 ones 3 minus 1 is 2, or we can directly take 2 as our result also. Now RHS for this is when we take n as 1, so 1 times 3 times 1 plus 1 divided by 2. So the result is 3 1 is 3, 3 plus 1 is 4, 4 by 2 is 2. So we got LHS and RHS same. Therefore we can say that P1 is true. Now for recall, mathematical induction is the process in which we do three things. First is P1 is true. We show P1 is true. And second thing is we suppose Pk is true. And at last we show Pk plus 1 is true. This we suppose or assume, and this we prove. This also prove. So this is the three things we have to do while solving the problems related to mathematical induction. So our first work is done. P1 is true. Now we suppose Pk is true. That is, while replacing n by k, we get 2 plus 5 plus 8 plus and so on 3k minus 1. We just replaced n by k and it equals to k 3k plus 1 divided by 2. Now we have to prove Pk plus 1 is true. That is, what we have to show is 2 plus 5 plus 8 and so on 3 times k plus 1 minus 1 equals to, so replace k by k plus 1 here, so that we have to prove k plus 1 times 3 times k plus 1 plus 1 and divided by 2. So let's take the result of the statement of LHS, that is 2 plus 5 plus 8 and so on, plus 3k plus 1 minus 1. Now 2 plus 5 plus 8, and we can write here the term just before this term is 3 times k minus 1, and after this term we have 3 times k plus 1 minus 1. But we have supposed that pk is true, so that in the place of this, what we have supposed here, 2 plus 5 plus 8 plus and so on, 3k minus 1 can be written as k times 3k plus 1 by 2, because we have supposed that pk is true. So in place of this term, this value, we can write k times 3k plus 1 by 2. So in the place of this expression, we can write k times 3k plus 1 by 2 plus 3 times k plus 1 minus 1. Now we can take LCM. We can take 2 as LCM. 2 times k times 3k plus 1 plus 2 3 is 6, k plus 1 minus 2 is 2. Now simplify this. What we get is 3k square plus k, 6k plus 6 minus 2, and it is 2 divided by 2. Okay, now this is 3k square plus it is 7k plus 7k plus 6 minus 2 is 4, and it is divided by 2. Okay, now I think we can factorize this expression, because 3 4s 12 and 5 plus 2, no 3 plus 4, yes, 3k square plus we can factorize this, so that it is k times 4 plus 3 plus 4 divided by 2. So 3k square plus 4k plus 3k plus 4 divided by 2. Now it is 3k times our common is k, so 3k plus 4. From here we can take 1 as common, so 3k plus 4 divided by 2. Now this is 3k plus 4 k plus 1 divided by 2. Now k plus 1, first write k plus 1, and 3k plus 4 we can write this as, so we have to prove this result is this, RHS is this. Look at here, k plus 1, 3k plus 1 plus k. So write this in form of that, 3 times k plus 1 plus 1 divided by 2, because while we simplify this we get 3k plus 3 and 3 plus 1 is 4. So our R is obtained. So we can write the statement, above statement is true. Therefore the above statement is true. So we will get by mathematical induction. Now at last we can write, therefore by mathematical induction, above statement is true. So this was the first question we have done. Now next question we have is this question. So let Pn equals to, Pn is 1 square, 3 square, 5 square and so on, 2n minus 1 square equals to n times 2n minus 1, 2n plus 1 divided by 3. Now our statement is this. Now at first we show P1 is true. So for P1, replace n by 1 in this statement. So while replacing n by 1, our LHS is 2 into 1 minus 1 whole square. So we have to replace n here. So 2 times 1 minus 1 whole square is this. So this is 2 ones 2 minus 1 is 1 and square of 1 is 1. So again we replace n by 1 in RHS. So it is 1, 2 into 1 minus 1, 2 into 1 plus 1 and it is divided by 3. So what we get from here, it is 2 ones 2 minus 1 is 1 times it is 2 ones 2 plus 1 is 3 divided by 3 and it is 1. So LHS and RHS are same, therefore we can write P1 is true. So P1 is true. Now we suppose Pk is true. So that is 1 square plus 3 square plus 5 square and so on, 2k minus 1 square equals to, so in this case we have to replace n by k on our statement, so that k times RHS is k times 2k minus 1, 2k plus 1 divided by 3. So it is 2k minus 1, 2k plus 1 divided by 3. Now we have to prove this. Now we have supposed this, and what we have to prove is Pk plus 1 is true. That is, we have to prove this 1 square, 3 square plus 5 square and 2 times. So in the place of k we write k plus 1 minus 1 whole square. On the right side also we replace k by k plus 1, so it is 2 times k plus 1 minus 1, 2 times k plus 1 plus 1 divided by 3. So we have to prove this. Now taking LHS equals to 1 square plus 3 square plus 5 square and so on, plus 2 times k plus 1 minus 1 whole square. Now 1 square, 3 square, plus 5 square, and so on. Now just in front of this k plus 1th term there is kth term, so that we can write 2 times k minus 1 whole square plus, and after this is kth term, and now k plus 1th term is 2 times k plus 1 minus 1 whole square. So in this case just replace the expression, because up to here this is our supposition. Look at our supposition. So up to here we can write k times 2k minus 1 2k plus 1 divided by 3. So in the place of this expression we can write k times 2k minus 1 2k plus 1 divided by 3, and plus this is what we can just simplify this, 2k plus 2 minus 1 whole square. Now we take LCM, 3 as LCM, so that k 2k minus 1 2k plus 1 plus this is 2k 2 minus 1 is plus 1 whole square. Now we can take common as 2k plus 1, because 2k plus 1 is here and 2k plus 1 here also, so that 2k plus 1 on taking common we can write k times 2k minus 1 plus here 2k plus 1 divided by 3. Okay, so simplification is going on. Now after this let us do next steps. So this is 2k plus 1 as it is. Now simplify this, 2k square minus k plus 2k plus 1, and this is divided by 3. Now 2k plus 1, and this is 2k square, so 2k minus k is plus k plus 1 divided by 3. So can we factorize this? And no. So what we have to prove is k plus 1 times 2k plus 1 minus 1 2k plus 1 plus 1. Okay, we have to take out factor as k plus 1. So can we factorize this? I think no. Let's check whether we have done mistake or not. So 1 square, 3 square plus 5 square plus so on, and it is 2k plus 1 minus 1 whole square. So this is 1 square 2k minus 1, because just in front of kth term there is k plus 1th term, there is kth term, and this is the value of this that we have supposed, k 2k minus 1 2k plus 1 divided by 3. This is the value, k 2k minus 1 2k plus 1 by 3. And next is 2k plus 1 minus 1 whole square, that is on multiplying this 2k plus 2 minus 1 whole square. Okay, yeah, this is we have done we have to tell LCM as 3, so that 3 times 2k plus 1, here is some mistake, so that this will be 3 times 2k minus 1. Okay, now after this, so after this we have calculation 2k plus 1, and this is 2k square minus k plus 6k, this is 6k plus 3 divided by 3. 2k plus 1 as it is, and this is 2k square plus this is 5k, 6k minus k is 5k plus 3. Now we can factorize this. 2k plus 1, and this is 2k square plus k times, and this is 3 plus 2 plus 3. 3 plus 2 is 5, and 3 to the 6. Yes, this is correct. This is 3. 2k plus 1, and this is 2k square plus 3k plus 2k plus 3 divided by 3, and this is 2k plus 1, and this is k common. Now 2k plus 3, and taking 1 common, 2k plus 3 divided by 3. Now 2k plus 1 and 2k plus 3, 2k plus 3 is common, so 2k plus 3, and we have k plus 1, k plus 1 divided by 3. So we can write this as k plus 1, 2k plus 1, 2k plus 3 divided by 3. Now RHS, take RHS. RHS we have, let me see, we have this RHS. So this is our RHS, k plus 1. Okay, write this. Our RHS is this, so that's right. Write this. RHS is k. Sorry. This is our RHS. So k plus 1, 2k plus 1 minus 1, 2k plus 1 plus 1 divided by 3. So this is our RHS. Now simplify this. K plus 1, so we have 2k plus 2 minus 1, and this is 2k plus 2 plus 1 divided by 3. So this is k plus 1, 2k plus 2 minus 1 is 1, and this is 2k plus 3 divided by 3. So look at here, this result and this result are same. It means LHS and RHS are same. So we have proved pk plus 1 is true. So we can say that therefore for, or we can say by mathematical induction method, Pn is true for all integers So in this way we can solve these questions. So we have last one more question, which is this. So let Pn is 4 plus 8 plus 12 plus and so on. 4n equals to 2 times n plus 1. Now as similar as previous method, so P1, for P1 we check. So for n equals to 1, LHS equals to, so here we put the value of n as 1, so it is 4, and the RHS is 2. RHS is 2 times n, that means 2 into 1 and 1 plus 1, which is 2 ones are 2, bracket 1 plus 1 is 2, and this is 4. So we got the same result, LHS and RHS. So therefore we can say that P1 is true. Now we suppose PK is true. We suppose PK is true, that is 4 plus 8 plus 12 plus and so on. 4k equals to 2k, k plus 1. Now we show pk plus 1 is true. That is what we have to prove is just replace k by k plus 1 here. So in the place of k, write k plus 1. So here also k plus 1, and in the place of k plus 1 plus 1. So this result we have to prove. So again take LHS, 4 plus 8 plus 12 plus and so on, 4 times k plus 1, and again 4 plus 8 plus 12 and so on. The term just before kth term, k plus 1th term is kth term, so 4k plus 4 times k plus 1. Now this result we have already supposed for this result that 4 plus 8 plus 4k can be written as 2k k plus 1. So in the place of this we can write 2k k plus 1. So we have next term 4 plus 1 k plus 1, and k plus 1 can be taken as common, k plus 1, and we have remaining 2k plus 4. So this is k plus 1. We can take common 2 from here, so k plus 2. So this is 2k plus 1, k plus 2, and this can be written as 2k plus 1, and this can be written as k plus 1 plus 1, because k plus 1 plus 1 is 2. So this is the same result as our RHS. So in this way we can say that pk plus 1 is true. Therefore by principle of mathematical induction, given statement Pn is true. Okay, thank you so much guys. I will be back with new video. So till then, thank you so much.